There is an ongoing global meltdown. A hole in the atmosphere is leaving us exposed to the sun's death rays. 4 brave young students dared to go on an adventure in order to save the world. Their odyssey consisted in going to the lake of the outskirts of Mexico City and taking water samples in order to then measure the level of pH. Stay tuned for the development of this dangerous journey. The results will amaze you. Basically, the quartet took samples from 4 locations, which can be seen on this map. Sample 1 was taken near the lake's shore, where several trash residues were present. Sample 2 was taken from a small stream that led to the lake, where water was constantly flowing. Sample 3 was taken from a point deeper into the lake, around 3 meters from the shore. Sample 4 was once again taken near the shore of the lake, but without trash residues. The foregoing heroes' hypothesis consisted in finding a large disparity between the pollution in Birmingham and the pollution in Mexico City, probably due to the differences in population, regulation, environmental policies between Mexico and the US. Once the water residues were collected, pH paper was used in order to test the results. Before going into it, it is important to briefly describe the carbon cycle, pertinent to the explanation of the water's pH.
The acidic pH levels of the lake on the Marquesa shows high concentrations of carbon dioxide on the atmosphere, since carbon dioxide.
For this project, we took soil samples in a 1-mile radius around Alabama, and our results were we took soil samples from a lake, the Walmart parking lot, a factory lot, a highway, and a gas station. And our overall results were the lake's soil pH was 8.5, the Walmart parking lot soil's pH was 7, as well as the factory lot soil pH was 7, and the highway and the gas station pH had a total soil pH of 6.5.
Along with pH, soil can be acidic and basic. The pH in soil is an important factor in determining whether or not plants will grow. It controls which nutrients will be available for the plant. Plants primarily need nitrogen, phosphorus, and potassium in large quantities. These are the plant's macronutrients. Other nutrients are needed, but only in small quantities. These are the micronutrients. The availability of the nutrients depends on the rate they are released from the soil and the pH of the soil. Macronutrients are more available in soil with a high pH, while micronutrients are available in soil with a low pH, as shown in this chart.
So basically what happens is that the high levels of pollution made by factories and by cars in Mexico City leads to a higher degree of carbon dioxide in the atmosphere. This in turn goes to the clouds, which then return this in the form of acid rain. And this falls on the lake, which is acid deposition, and because of that, the water in the lake have a very low level of pH.
Soil pollution occurs when the presence of toxic chemicals, pollutants, or contaminants in the soil are in high enough concentration to be a risk to plants, wildlife, humans, and of course the soil itself. Arable land is turning to desert and becoming non-arable at ever-increasing rates due largely to global warming and agricultural fertilizers and pesticides, lessening the hope that we can feed our booming population. In addition to that, soil pollution is primarily caused by man-made waste. Human waste products such as engine oil are full of unnatural chemicals that damage soil.
The main effect of soil pollution is a change in the pH level of the soil. The change in pH can affect plant growth, plant fertility, and in some cases humans. The change in pH can also reduce the amount of available nutrients in the soil and expose the soil to toxic nutrients. This lowers the fertility of the soil and it can reduce the likelihood of plants growing in that area. For humans, in cases that plants and crops do grow in toxic soil, they can absorb the pollutants which can then be transferred to us. This can cause short-term or even terminal illnesses.
Methods of conservation include revegetation, which involves deliberate planting, suppressing of fire, grazing to allow regeneration. Also, slope runoff control includes terracing, deep tillage, and application of humus, which is the organic compound of soil, transverse hillside ditches to intercept runoff, contour plowing, and preservation of vegetation strips to limit field width.